Project management is governed by the iron triangle: time, money, and quality. Time is tracked by deadlines. Money is tracked by budgets. But that third pillar is notoriously difficult to pin down. Clocks count hours, and spreadsheets calculate dollars. Measuring a standard of physical excellence before a product leaves the factory is entirely different. Often, companies only discover a flaw when a finished component physically breaks in the real world. Consider the Takata airbag crisis. Millions of inflators were recalled after they deployed improperly, costing billions of dollars and destroying decades of consumer trust. That is the literal cost of unquantified quality. A business cannot leave excellence to chance. It must build a rigid mathematical architecture to measure exactly how well a product is made, step by step. That architecture is called a quality management system, or QMS. It acts as the master blueprint of a company, a codified set of rules, policies, and processes specifically designed to guarantee customer satisfaction. To function, a QMS splits into two interlocking gears: quality assurance and quality control. Assurance is proactive, preventing defects by engineering flawless processes and assembly sequences. Control is reactive, relying on methodical, mathematical inspections of the actual output to catch defects before they reach customers. To execute that control on the factory floor, workers need specific, data-driven instruments to translate the abstract idea of perfection into simple, actionable math. This is where the 7 basic tools of quality come in. These are a fixed set of graphical techniques designed to troubleshoot production issues using highly visual, straightforward math. These tools were developed in post-war Japan with a specific goal. Anyone, from a boardroom executive to an everyday worker on the assembly line, should be able to interpret the data without a degree in statistics. The very first step of quality control is capturing raw, real-time data exactly where the product is being made. For this, workers use a check sheet. This motor assembly check sheet organizes discrete defects into a readable list to log issues as they happen. Making simple tally marks lets workers immediately see which errors pop up most. Here, rusted parts clearly dominate Monday and Tuesday. A check sheet perfectly captures the raw data of the moment. However, scanning pages of tally marks makes it difficult to spot deeper, long-term trends at a quick glance. To solve that problem, quality control teams take those raw tallies and convert them into a histogram. This animated chart is a histogram. It uses vertical bars to instantly visualize the distribution of data. Instead of counting individual marks, you can immediately see the central tendencies of the process, making any glaring anomalies or outliers blazingly obvious. Finding an anomaly is only the beginning. The business then has to track the ongoing process to determine if that defect was an isolated accident or a systemic failure in the machinery. To do that, they use a control chart, plotting sample data chronologically to monitor process behavior hour by hour. Using historical performance, it establishes upper and lower control limits. If a data point spikes violently above that boundary, it triggers an immediate visual alert. By comparing current data against these historical limits, a company instantly knows if their manufacturing process is stable and predictable or entirely out of control. Throwing away a defective part only solves a temporary problem. The true value of these quality control tools lies in feeding that precise data back into the larger manufacturing system. Many organizations use Six Sigma's DMAIC framework: define, measure, analyze, improve, and control. The hard numbers from histograms and control charts flow directly into the measure and analyze phases. With this analysis, management implements a permanent fix during the improve phase. This continuous feedback loop ensures that the company is repairing the underlying manufacturing systems rather than constantly treating isolated symptoms. This relentless cycle of tracking, analyzing, and improving creates a culture known as total quality management, or TQM. It is a philosophy championed by post-war statisticians like W. Edwards Deming, who helped modernize industrial production. Under TQM, quality shifts from being the final inspector's problem to the active responsibility of every single employee. A comprehensive quality management system serves as the grand blueprint for a successful company. But the everyday quality control tools,
The check sheets, the histograms, and the control charts are the crucial sensory organs. They allow the business to see its flaws, adapt to variations, and ultimately achieve a standard of measurable perfection.